Hello everybody, today I would like to continue our Java serialization series and we will approach now the serialization of enums in Java, and we will do some refactor of our code because it's becoming quite complex because we are serializing every type of object. So we start to have a lot of conditions, ifs, and so on. So as promised from my last video, I just did a small refactor, but quite effective, and so the code can be clear to anyone that wants to read the code. So the first thing that I did was just to add an enum, how to serialize enum. Enum is a little bit tricky because in Java, as you know, enums are class. So I will run an example so you can see the output and why I took a few decisions along the way. So in our user, and if it's your first time seeing this video, please review my previous video at least. Probably in that video I will say for you to review the previous one, but somehow each video focus on a specific thing and you can learn from it. You don't have to check the other videos to learn about how to reflect specific data types that I describe in the title of the videos. So returning again to our subject, so I've added here a new enumerator type called user type, and the enum should be here. It's an enum with just a regular admin and guest, meaning that a user can be a regular user, like a common user in a company, admin, who can do more stuff, and the guest usually don't have too many permissions, such reading some files or reading some websites. But in our case, we are studying reflection, so it's not important the permissions or authorizations for each one of these roles. So our main focus is about how to serialize an enum. So let's return to our main. So I run this code, which is creating a user and call the serialize using fields version 3. My previous videos, of course, was version 1 and 2, and these are the versions that I'm thinking to develop next. So let's see the output. All these formats are explained in my previous videos. The one that interests is this one. So I decided to, when I serialize an enumerator, I use the name of the property, meaning that this name here. There are several reasons for that. You have an alternate way to do it. You can go using, for instance, the ordinal number behind it. As you know, this is number 1, number 2, number 3. For instance, on the enum, they have a sequence. The problem is when we are exchanging information about the enumerators between systems. Imagine in a microservice architecture. If you are serializing an object, probably you want this serialization to be used by another system, and it's clear that I'm targeting admin rather than use, for instance, a number like 2 or 3, or in this case 0 or 1 for admin. What does it mean? And if I change the order of this, imagine that now I will do some kind of alphabetic order and start with admin, then guest and regular. So it will be incompatible with previous requests on our behavior in our system. So it's better to use the name of the properties in the num rather than use the ordinal number, because sometimes we think, okay, maybe the ordinal it's better because it's an integer, so it will be easier to handle. But the problem is it loses the descriptive or the inherent value of a numerator in Java, and the value of a numerator, it's more human readable. It's better to read Monday than 0 or 1 as the first day, because if later we change the order, it will be complicated to make the systems compatible. But if you use names, it's clear. It doesn't matter what is the order. The name, it's the name. So of course, the other system should know that we are sending admin, and it should know how to transform this admin to a string or integer or whatever. But it's better for everyone. And at the end of the day, we are humans developing code, at least for now, waiting to see the future of the AI. So let's return to our serialization. So we have in our main serialize with this output. So how to serialize an enumerator? I've created a class. I'm going to explain later how I refactor this code. But for now, let's go to the serializer. If you saw my previous video, you see a lot of a lot of changes in the code, but I think it's more readable now. I don't say it's the final version of our refactor, but at least it's more readable. So let's find out where is the enum. I created a switch for the data types that we were serializing before, and I created a specific if just for the enum, because enum is a kind of a class data type, and the other data types that we're using were somehow, let's say, native-ish, because local date time, and date, they are classes. But at the end of the day, so is string, so is integer, like a wrapper or short or boolean or whatever. Okay, but I split classes, custom class, let's say like that, from the, let's say, native-ish, as I call them in Java. So it's clear. So these are the ones that are simple to serialize, because you don't expect inner objects inside of them. We just serialize directly, calling the toString or any other method. But for instance, class data types, they can have other classes inside, and that will be trickier to serialize, something that we'll address in my next video, version 4, where we start to think about class inside class, meaning that we will have a recursive serialization. And after that, we have almost a complete version of our serializer. Not the serializer, which will be a different challenge, but at least the serializer. So let's see what I did for the enums. The first things to do is just to ask to Java what if the field get type is enum. And it's quite nice because we already have a method called isEnum. Okay, and I created a method called serialize enum. In my previous video, there were a bunch of if conditions here. Now I just split and we have a specific method for each type, what I think it makes the code clearer for anyone. But let's see our serialize enum here. And the serialize enum, I wrote the two possible versions and the expression I did before about why I choose the name like this one, admin, rather than the ordinal. But how to get it? First, the way to get the enum is by using field get. It's like getting any class from the field, but we should guess to this one. We don't know the data type of enum, because at the end of the day, the user type, it's an enum, but behind the scenes is just a class, a generic class with a type user type. So meaning a class user type, but in our case, enum user type, like we have, um, yeah, here, okay, enum, and this is the data type which will be our user type. So when since we have this enum, generic enum, we can do questions or have specific methods just for enums and not generic class, like say like that. But at the end of the day, an enum is a kind of a class, okay, with specific restrictions, as you know. So you should have, for instance, uh, private constructors. It doesn't allow, for instance, public constructors. So, but at the end of the day, just do a code. We get the name of the enum, which will be this admin between quotes. If you use the ordinal, it will be a 0 or 1 depending on the order. And as I said before, it's not a good idea when we are using serialization to exchange methods like calling web services, because when you do a REST call and you put an object, it will be serialized to JSON. So in this case, I, I I prefer to use the admin rather than the number. And it's quite simple. It just get the name. This is the trick to using the name. It's first is using this cast here for the name, and then get the name. The name will be these names here: regular, admin, guest. Okay. The other way, just the ordinal. The ordinal will be the number behind this regular, admin, and guest. Okay. But this is for generic. Remember that we are using reflection for generic objects. There could be other ways to get values from this object. Imagine that you have a specific get here in our enum. As you know, we can add methods here, constructors, and so on, and we want a specific value, different value. In that case, probably we should address that in our serializer configuration that we are using for the formats, but we can use, for instance, for specific enums, but it will be a very advanced and very custom-made JSON serializer. We are just targeting the common, but there is no reason if you want to go further and push the boundaries on how to serialize enums. But okay, let's start simple, and then the start simple. Later we can build um, um, uh, above this simplicity with more complex solutions. Okay, but again, this is the serialized enum. We always need an object, the field, and the JSON where of course, the JSON will be appended like this. Okay, I did for the other types, serialized string, serialized boolean. I just copy paste or move the value or extract the value from our serializer. Our previous version was if something get type is something, then we JSON append and we call the format and so on. If you check my previous video, you'll see how we were doing. Now it's very simple for the data types. We just do, if it's a string, we get the simple name. The simple name, it's the simple name of the class without the package part on the left part. So if it's a string, it's a string. If it's one, rather than check if it's a number, we can check directly if it's an int, integer, long, the names that we already know for the data types. There are a bunch of them here. I think there's 2, 4, 6, 8, 10, 12. It's 6 data types or native data types that they have wrappers. But again, serialized number, you just pass the object, the JSON, and the possible configuration. I explain in a moment why. But this configuration has, for instance, the format that you want for a double or a float. The same for Boolean, serialized Boolean, the local date time. They can have different serialization formats, and of course for the date and the enum we already saw it, and then it's the same code that we had before. The only thing that we did was just to serialize enum and refactor the code. So how did we refactor the code? Let's go. And so first I create a serializer configuration. For now it's just a simple one, not too advanced, but we just remove the static from the formats. I remove it from the serializer, which was here, and now it's just a specific class, so you can have different configurations for the different context serializers if you want. I added the float, the same as the one that I had in double, and of course you have a constructor, but I open the gets and sets freely. It can be, we can change the format every time we want for each call. Okay, it's just a specific class, meaning that in the main we create a configuration. I am only changing the double format here, which will be this output here, you can see. Okay, and then I'm calling the serialize using fields, the serializes that we were seeing here. Okay, with our switch, our field, and I pass configuration in the parameter. This configuration, of course, is received here on the configuration on the parameter of the serialize. And then when it for the types where it is relevant, like local date, date time, date, or even for the serializer number, I pass as a fourth parameter here. Okay, for string, there's no reason to for the format. It can be, but it's usually we don't want to format the content of a string, but because the content of the string is something that is semantic. Because someone can ask, okay, but we have the string format that we can use, but I don't see any reason for a serializer to know about the format of a specific string. Maybe the string should be formatted before on the object because it's a semantic thing, and later the serializer just serialize the string and it will be deserialized on the other side. I don't see reasons for this. When there is a reason for that, maybe you should format before calling the serializer. The serialization is about compatibility between systems, and doubles can be a problem, dates and things like that. But the content of fields, changing the format of a string, it's like I want to transform a number to, let's say, a different type like log power or something like that. It doesn't seems right from the semantic point of view. Okay, so we have our serializer again, um, and we created this JSON serializer helper with the serialize for each type. And as I was saying, we have this fourth parameter in some of them, and each one knows what to get. So for the double, it will call the get double format. For the float, we'll get the float format. If you go to the dates, let's should be somewhere here, like here. Okay, the local date will get, of course, the get local date format, and so on. So before we call the serializer, we can always create an instance of a configuration. If you want to change the default values, like we have here, they all have default, and they should have a default value, because we cannot ask for someone to say, okay, you should explicitly fill all the possible configuration values. It's a very good practice to always have a default value for configuration. So we have, again, our main here. I'm just changing this double format to use 2 decimal digits here, okay, like we have here. And if you see the value, you can see that it was expected for, but we are forcing just to make sure that we are the configuration is working. Then we call this serialize using fields version 3 with our refactor code, and this is the output. Just run it one more time. And okay, this is the output. So our serializer, it's as advanced one more level. Now it accepts enums. And for the next versions, we'll start to do the composite objects, meaning class inside class, and then, of course, the collections and arrays. But after the composite objects are working, the collections arrays will be quite simple, because if you think for a while, you just have to check if you have a collection or an array, and then you should do a loop and go through all the items of this collection and recursively call again the serializer. Because inside an array can be another array or another class, and which, by the way, this class can have an array, and so on and so on and so on. Later we'll let's say professionalize our code and add annotations. So this configuration, probably it will be removed for a while, because sometimes there are other configurations, but the idea of the annotations is to say, okay, the format for this specific field, it is this one for this specific date. Okay, I don't want to go into much details here, but sometimes you want to have both annotations and the configuration, okay? Because you can have a class that meanwhile is version changed and annotations change the format, but you are still reading previous versions and you want to force a previous format using, for instance, a configuration like this rather than use annotation. Okay, I'm previewing 2 versions from now, but it's a challenge if you are starting to think about how to implement a serializer and how do they work, and why sometimes the serializers have both annotations and the other one. It's like it seems redundant, but it's not. Sometimes you have both, because they can be very useful in specific formats, mainly when we are using legacy code. And then later we will change the fields, which is not a good practice like we are doing now, and start to use getters rather than the fields, because we are using fields, but let's think for a while. Fields, sometimes they have values that shouldn't be serialized. For instance, a password. Maybe we don't want to serialize a password, or maybe internally we have the real password, but the get method, for instance, hashes the password, and we just want to hash serialize it and not the real password. This is just one of example. There are other examples that I could talk about. Okay, so in summary, our code currently, we have a serializer, of course. It's our version 3 that receives an object like user, for instance, our user here, and serialize it. It can accept a configuration for each execution. That's why it's a parameter. Otherwise, it was not necessary to be a parameter, and you could just use static fields. But sometimes for different objects, you want different serializations configurations. So it's a good practice to pass as a parameter. Then we have a loop for each field. Okay, make sure that we set accessible to true, so we can access private fields. And then we just check which data type belongs to each field, and if it's one of these, we call just serialize string, serialize number, boolean, local date time, date, the ones that I call native-ish data types, because they are not, let's say, composite class, okay? Because local date, it's a class, but it's a kind of immutable class, so let's call it somehow native-ish in the class like strings, okay? But then you can have specific class that can be composite. And we are starting to include now first the enum, later other data types. Okay, and that's it. It's a very simple. You know that the code now is just a few lines, not a lot of ifs with inside another if conditions. It can be very complicated for human. Here it's easier to read. Just what is the type that I'm handling, okay, and just call a method, a specific method for that, meaning that we can reuse these methods in other scenarios. And I created a class, a specific class for these ones, which is called serialization helper, because it helps the serialization. And how does it help? It knows how to serialize a local date time, local date, serialized number, and so on. And we have the user type, our an example for our enumerator, and a possible configuration, JSON serializer configuration. We have another class that we created before, called format utils. It's not called helper because it's very generic. It doesn't have JSON because it doesn't target JSON, just format dates. It knows how to format the date. Okay, a local date time, local date, and it can format even if it's not being used to a JSON serialize. You can use it for other scenario. So this is the code currently that we are developing now, and it's our current version. It will be improved, as said before, and promise for version 4 will start to include composite objects. I didn't put any link to this code if you think you want it. Usually the code you can, if you follow the videos, you can write it yourself. You can just pause the video and the code is what it is, and you can develop. And that, for me, it's the best way for you to learn. But if you want, I can share the code. I can put this on GitHub, and you can just check, download, and play with it. But I usually prefer that people, at least I myself, I like to write code when I'm learning. It's like using a pen when you are studying. It gives you some boost in your associative memory, and you start to remember your experience doing things rather than hearing about things. But if you think it's useful for you, I can share the code. There is no secret here, no copyright, nothing. You can just use it if you need it. Okay, so I hope you liked this video. Be free to comment, like it, subscribe, share with your friends. Um, I have a lot to talk in other videos, a lot of ideas. I'm just now pushing this serialization series. It's very important, and because I have worked before and I still work in enterprise in computer, and sometimes people just use REST API, but they don't know behind the scenes, and even in other scenarios that the serialization is used in a lot of different places when using messaging systems, REST APIs, saving state of objects in session in web. And if you understand how the objects are serialized and what are the challenges when you are developing a serializer, I think it will make you a better professional on this area, and can be really, really useful in some troubleshooting scenarios. So I hope to see you in my next video, and thank you for watching.